This lesson deals with supplemental problem 411. You can find this problem in the ECE302 ebook in the Chapter 4 Supplemental Problems on page 18. The circuit shown below is from a magazine article in Popular Electronics in Volume 22, Number 1, from pages 96 to 103. And the article was entitled Rediscovering the Transistor by Forrest Mims. This is a collection of transistor-level circuits, many of which were MOSFETs. And this particular one was labeled Off After Time Delay Alarm. It consists of an N-channel MOSFET, a fairly large capacitor and large resistor in parallel, a switch, a piezoelectric buzzer, and a 9-volt battery. Let's assume that the switch S1 is pressed, held down, and then let go at time t equals 0. Could you determine an equation for the gate source voltage, which is between here and here, versus time? This particular buzzer needs at least 3 volts across it at 1 milliamp to make a sound. This implies that the buzzer will sound as long as the drain source voltage is less than or equal to 6 volts. The drain source is 6. What's the gate source if we assume that we're in saturation? And then how long will it take for the gate source voltage to reach this value? That is, how long will the buzzer buzz? So the switch is held closed for a long time and then let go. What that implies is that we've got 9 volts right across this capacitor. It's going to be charged up to 9 volts. With this open, we've got an R and a C in parallel, because this looks like an open circuit between the gate and the source. We've got a decaying voltage across the capacitor. In other words, the capacitor voltage looks like some A plus B times e to the minus t over tau. And tau is going to be the resistance seen by this capacitor. Again, this is open. This looks like an open circuit. It sees 22 megohms. The product of those two is the time constant, and that's 220 seconds long. The initial condition, the value of the capacitor voltage just before we let go, is the same after we let go, and that was 9 volts, and that's going to be A plus B times e to the 0. And if you wait long enough, this capacitor will discharge. This equation will approach 0 as t approaches infinity. When t approaches infinity, this term is 0, so that means that A is equal to 0. And now we can solve for the capacitor voltage. It's going to be B, which is equal to 9, times e to the minus t over 220 seconds. This will be true for t greater than or equal to 0. Our conditions for the buzzer to shut off is that the drain source voltage is 6, the buzzer is 3, and we've got a milliamp of current going through it. Assuming that we're in current saturation, so we'll take our current saturation equation, solve for the gate source voltage like we did previously, and it's going to be I sub d divided by k square root, plus or minus roots, and then bringing the threshold on the other side. We know the value of the drain current is 1 milliamp. The value of k was listed above as 625 milliamps per volt squared, and our threshold voltage was listed up above as 2 volts. That's going to give me 2 roots. I didn't list the other root. It was less than threshold, but the one that's above threshold is 2.04. We should check that we are in the current saturation region at this point. We need to find the gate to drain voltage to do that check. And the gate is equal to 2.04, and the drain is equal to 6. And the difference of those two is a minus 3.96 volts, and that is less than or equal to threshold. We are in current saturation. Let's take this equation and determine the time t it takes to drop from 9 volts to 2.04 volts. Let this equal to 2.04, and we'll say that t is equal to some time t1. And now let's solve this. Let's take this on this side of the equation, so I have 9 divided by 2.04. Bring this on this side of the equation, which is e to the plus t1 over 220. Then take the natural log of both sides of the equation, and you'll get the natural log of that ratio, and then cross multiply by 220, and that's the value of t1. And that's 326.5 seconds. Convert that to minutes, you get 5.44 minutes. This alarm will stay on 5.44 minutes when you let go of that switch. And that could be a trip switch on a door or some kind of thing you're trying to protect. And a supplemental problem 411.